Module 3.5, Interference and Superposition of Waves. When two or more waves meet, they combine, and as they combine, they add together algebraically. That means that the amplitude of each wave is added, keeping track of the plus or minus sign when adding. Here's an example. On the bottom, we have two identical in-phase waves with the same amplitude. Let's add different points of the bottom two waves together. At 0 degrees, amplitudes of 0 plus 0 equals 0. At 90 degrees, 1 plus 1 equals 2. At 180, 0 plus 0 equals 0. At 270, minus 1 plus minus 1 equals minus 2. And so on down the wave. When we plot those points, we get the top wave, which is a sine wave with twice the amplitude. Now, here are two identical sine waves that are 180 degrees out of phase. Let's add different points of these waves together. At 0, amplitudes of 0 plus 0 equals 0. At 90, 1 plus minus 1 equals 0. At 180, 0 plus 0 equals 0. At 270, minus 1 plus 1 equals 0. And so on down the wave. You can see on the top that they cancel each other out. Here's a dynamic way of seeing the effect of combining waves. A purple and a green wave meet at a bar. When they combine, they create a green wave that is the algebraic sum of the two waves. As they move further and further out of phase, you can see that the amplitude changes as they interact. If the amplitude of the combined wave is greater than the amplitude of either wave, we call this constructive interference. If the amplitude of the combined wave is less than the amplitude of either wave, we call this destructive interference. Now, there is an interesting phenomenon that happens when waves combine. It is called the principle of superposition, which states that the existence of one wave does not affect the existence or properties of another wave. This means that waves can pass through each other, and after they are done, they continue on their merry way unaffected by the meeting. Here's some examples of superposition. This explains why we can hear in stereo. One speaker does not erase the sound coming out of another speaker. This also explains how noise-canceling headphones work. Noise-canceling headphones have a microphone that takes the ambient noise and then feeds it into the headphones with reverse polarity, which causes destructive interference of the ambient sound, canceling it out. But because of superposition, the music still comes through. To review, when two or more waves meet, they combine and add together algebraically. Constructive interference occurs when the amplitude of the combined wave is greater than the amplitude of either wave. Destructive interference occurs when the amplitude of the combined wave is less than the amplitude of either wave. The principle of superposition states that the existence of one wave does not affect the existence or properties of another wave.